Hey, me again. Welcome back. Welcome to day, I don't know, what are we, 3 maybe into genetics? We've covered just kind of the introductory basic terms you'll need to know for this unit and understand, as well as Punnett squares. So hopefully you're feeling really confident in understanding everything we've done thus far. If you still have questions on Punnett squares, please make sure you are reaching out to your teachers for further understanding of that material. Today we're going to talk about incomplete and codominance and what that entails. So just a couple other different types of crosses that you may encounter. We're going to start by talking about incomplete dominance. Incomplete dominance is when you have parents who produce offspring that don't look like either parent. In fact, instead, there is a blending that occurs between the parents' traits to get a different offspring result. So the example we have here is you have a pure red, or homozygous red down here. See, homozygous red down here, crossed with a homozygous white. You'll notice that all of their offspring then are pink. So instead of you having red and white offspring, or red or white offspring, you now have a blending of the two traits, the red and the white together, which creates then your pink combination. You'll notice that there's no recessives because we're talking about only dominant traits here. Incomplete dominance, so all capital letters, no recessives. So again, incomplete dominance is when neither parent's trait is completely dominant over the other. In fact, they're both equally dominant to create a blending unique trait in the offspring. So the pure red flower crosses with the pure white flower to get 100% of your offspring being pink in this example. So incomplete dominance is a blend. We then have codominance, in which both traits are present in the offspring. So instead of a blending of the parent's trait, you now have both showing up. So both traits are completely dominant. So in this example, we have I'm going to use the roan cow down here. You have a red cow being mated to a white cow to produce an offspring that is a roan. It's called roan when it's red and white both present. So this happens when you have like a spotted offspring or a multicolor offspring when they get both colors from their parents. So it's not a blend like in incomplete dominance, but it's a both are showing up in codominance. Another example of codominance you may have heard of is, let me pull this over if I can, is called sickle cell anemia. So what happens here is individuals that are affected with sickle cell have both nice, healthy, round, squishy, soft red blood cells that look like this, but they also have sickle cells that look like this shape, kind of a crescent moon shape. They're hard, they're rigid, they're sharp. It's a fairly painful, from my understanding, a fairly painful illness, but it is affected by, or it's being affected by a codominant trait. So co meaning both traits are present, both healthy red blood cells and also sickle cells. So just a little side note on that. Multiple alleles, and we'll get into talking about blood types here now. Multiple alleles are occurring when you have more than 2 possible alleles for the exact same trait. So we use blood type as a common example of this type of allele or system because it's very common. You have 4 different types of blood. You have O blood, B blood, A blood, and AB blood. You still only get 2 alleles, 2 letters for blood type, but they're all the same trait. It's all blood. So it doesn't matter if you, I mean, it does matter in a sense, but it doesn't matter if you have O blood like I do or A blood like my husband does, it's all blood. So there's multiple alleles, multiple different combinations of alleles for the exact same trait. Let me show you, let's see, anything else I want to talk about? So sure, so A and B are codominant in this case, so both can be present in an offspring, and O is going to be recessive. O is the most common type of blood out there. And again, your possible types are AB, and O, all for the same exact trait though. So more than one allele combination coding for the same trait is going to be a multiple allele like blood type. Here's just a chart to kind of lay this out. Here are 4 different blood types listed along this row here. The genotypes, so the letter combinations in the second column. The antigen is just what makes it that type of blood. I won't go into that too much here. Can I move you over? Kind of. Let me do this for a second. Let's stay here for a minute. So if you have A blood, your alleles are either AA or AO. Remember, A and B are both dominant. So if you have AO blood, you still have A blood because that O is recessive. That A masks or covers up the O. So the O, in a sense, is kind of neutral in this situation. So A blood individuals can either have AA or AO. B blood, you can have either BB or BO. AB, you only have AB for your alleles, and O, because O is recessive, is just OO. You can't see because I'm kind of covering up, but AB blood is a universal acceptor, meaning if you have AB blood, you can receive blood from any individual out there. It doesn't matter what type of blood you're receiving, your body will accept any of it. On the other hand, O blood, because it only has O antigens, it doesn't recognize any other type of blood other than itself. So it can only receive O blood. So there's a lot more that goes into blood types, but I'm just trying to keep it simplified for the time we have here. If you have other questions, please reach out. Feel free to ask us. You do the same type of cross when you're looking at blood types as you have in the previous examples we've given. So in these examples, you have a parent who's homozygous up here, homozygous for A blood, so AA, and another parent who's homozygous for B blood, so BB. Cross them, parents on the outside, cross them like you do any other way, combining in the middle, so all of their offspring would have AB blood. Over here, you have a parent who's AO, so that is heterozygous. Remember, different. Heterozygous for A blood. So here's homozygous AA, or heterozygous AO, but both of these are still A blood because that O is acting as a neutral placeholder. With a B individual over here, and these are the offspring. So you can look through and just see the other examples given, but you're doing the same crosses as you have in the past. And then last couple things, just a couple visuals to lay out just the way that donors and recipients, who can give to who. Remember, O can give to anyone. Anyone can accept O blood because that is that neutral kind of recessive donor. AB can receive any blood, so all the arrows are going to AB, and O can only go to O. Just how this is spread out within the United States, most 45% of people have O blood. A blood is the next most popular or common, running in at 40%, and then you see the following. You also are given an RH factor, it's called, of either positive or negative. If you have this RH factor or antigen, it's a specific protein present on your blood cell. If you have that specific protein, you're considered you having positive blood. If you don't have that protein present, then you have negative blood. A couple videos if you'd like to watch those just as some background or in addition to the information we've already provided, feel free, go ahead. I'm not gonna cover them right now, but I wanted to include them or leave them on this PowerPoint. Okay, you do have an assignment to complete using the information we've just provided with incomplete and codominance, as well as some blood type questions. So please go ahead and access that assignment and complete that and turn it in when you're through. Reach out if you have any questions regarding today's lesson. Thanks.